We're going to discuss the waterplane area and waterplane coefficients. Of course, if our vessel was a rectangular shape, as we see here, length times breadth, it would be very easy to calculate the area, the waterplane area, because you just simply multiply length times breadth. But the problem we've got, of course, is that the vessel isn't a rectangular shape. You have a ship shape here, and you can see it doesn't cover the whole area. So how do we solve this problem? Well, we need to work out our waterplane coefficient. And the waterplane coefficient, it's a ratio between our waterplane area and the actual length and breadth. So let's have a look at that in a little more detail. So I've done a sketch here, a brief sketch, and you can see I've shaded the areas here, in effect the length and breadth of the rectangular area that don't cover the ship shape. And in the centre there, I've called that the waterplane area, or AW, as you'll see on the formula sheet. And we know that area is length times breadth, metres squared, and the waterplane coefficient is the waterplane area divided by the length and breadth of the rectangular shape. Now, from that you can see that the maximum value could only ever be 1 for the waterplane coefficient. And that's because if the vessel was a rectangular shape, then its value, the waterplane coefficient, would be 1, because the length and breadth would be the same for the rectangular shape and the vessel. But of course we know that our vessels aren't a rectangular shape, so therefore a waterplane coefficient value is always going to be less than 1. And it has no units because it's basically a ratio between your waterplane area and your length and breadth. And on your formula sheet you'll see it written CW is AW over L times B. Or if we transpose that formula, we can say that AW is length times breadth times waterplane coefficient. And AW, we can imagine, or think really, that it's a percentage of the total area. So of this total area here, AW, waterplane coefficient, it's a percentage. So we can say that if we say that CW is 0.79, and when you look in your hydrostatic particulars, you'll see that CW is written just like something like that, 0.79, 0.81. What you can actually say is that it's 79% of the total area. So if we say our CW is 0.79, what we're saying is that this area here is 79% of the total of 100%. And on our formula here, as long as we know 2 of these 3 values, we can find the third. So if you knew the length and the breadth of the vessel, and you were told your waterplane coefficient, you of course could find your waterplane area. Okay, so if you know 2 of the values, you can find the third. So that's when we're looking at the waterplane coefficient. Now let's look at the block coefficient, which is along very similar lines. And what we're looking at here with the block coefficient, there we've got our shape of a vessel, underwater volume of the vessel, the ship shape volume, and then the actual box shape as well. And the same theory applies, that the maximum value this could be would be 1 if the vessel was a box shape. And of course it isn't a box shape, so the value of CB, which we're talking about now, which is block coefficient, CB, must always be less than 1, or 1 as a maximum. So block coefficient is the underwater volume of the vessel divided by the length times breadth times the draft of the box shape. Maximum value is 1. Again, there's no units because it's a ratio. And we require the underwater volume of the vessel. So again, if we know the length and breadth and draft of the vessel, and we know our block coefficient, again they're in the hydrostatic particulars, we can find the underwater volume. And if we know the underwater volume of the vessel, of course we can find our displacement. And that's the whole reason behind finding your underwater volume. Once you have your underwater volume and you know your density, you can find the displacement of the vessel, because on your formula sheet density is mass over volume. Mass in this instance is weight, volume is underwater volume. Therefore weight, or displacement, is going to be the underwater volume multiplied by the density of the water. And again, we can think of the block coefficient as a percentage of the total volume. So if we were to say that the CB was 0.81, what we're saying there is that this whole underwater volume is 81% of the total 100% volume. So really imagine those figures, 0.81, 0.79, whatever they are, as basically percentages of the total amount. And that's the covering of water plane coefficient and block coefficient.